Today I'll be talking about orthographic projection. So, what's orthographic projection? Orthographic projection is a method in which an object is depicted using parallel lines to project its outline onto a plane. Like, for example, the object might be an isometric, a pictorial diagram. So orthographic projection is just you projecting out lines to show the outline on a plane of the object. In orthographic projection, we have both first angle orthographic projection and also third angle orthographic projection. I will give you an example. Okay, let's talk about the first angle projection. The first angle projection. The symbol used to represent the first angle projection is shown like this. I'll be drawing a rough sketch of the symbol. So this is just a rough sketch of the symbol used in representing the first angle orthographic projection. Then, to draw the first angle projection in a plane, you have to draw the orthographic lines, which is a construction line. First of all, the orthographic lines will have a vertical line and also they have a horizontal line. Then if here is my front view, I'll draw my front view at this point. My plan view will be drawn at this point, and while my end or side view, we can say end elevation, we can also call this front elevation or plan elevation. Then while my side view can be drawn here. Now mind you, we have two side views. In this side, you draw your right hand side view, while in this other side, you draw your left hand side view. As time goes, I will show you why I mean or why we should draw the right hand side view here and also the left hand side view on this other location. We are not done yet. At this point, there's a line drawn here which is inclined at an angle 45 degree. At an angle 45 degree. Same here. At an angle 45 degrees. So, assuming you are given a question to draw both the right hand side view and also the left hand side view, this is how you draw your projection lines for the drawing. The front view will be drawn here, the plan view here, the right hand side view on this other side, and the left hand side view on this other side. So let's move forward. I'll give you an example. Okay, now for example, if you're given a question that looks like this, they say draw the first angle projection of the object in the direction x. If they should put an arrow and label it with any alphabet, maybe X, A, B, or something, it means that the arrow or the direction of that arrow will represent the front view, meaning that you should take where the arrow is pointing to be the front view. So we are going to take this direction as our front view. And if you look very well, from here to here is 70 millimeter, 15, here to here is 15 millimeter, then here to here is 30 millimeter, then here is 50 millimeter. Also from this point to this point is 15 millimeter. But we don't know from this point up to this point. So if you look very well, since here is 50 millimeter and here the height of this block here is, the thickness is 15 millimeter, it then means that this point here will be 50 millimeter plus 15 millimeter, which is 65 millimeter. So our height from this point down to this point will be 65 millimeter. So now, before drawing any orthographic drawing or representing the isometric in an orthographic projection plane, first of all, you assume that the diagram you want to draw is at your eye level. What I mean is, you imagine that this point, the bottom of the diagram, is directly at your eye level. Then you look the object directly where the arrow is facing. So for example, if I should keep or assume this object to be at my eye level, and I look at this object in this direction, I will observe two things only. The two things I'm going to see, or the two places I'll be seeing, will be this point here, this point, and also this surface here. Those are the 2 points I will see, or those are the two surfaces I will see. If I'm keeping it actually at my eye level, there is no point where I'm going to see this surface here, or see this surface here, or see this surface here. So let's go into our drawing. First of all, you always draw your projection lines. which is the orthographic projection lines, a vertical line, and also a horizontal line. And also a horizontal line. Then now I told you that if I'm to keep my front view here, that means my side will be here. But if I'm to keep my front view here, also my side will be here. So let me keep the front view. Let me draw the front view at this point. So now I will observe this point, which is something like this, which is this, and also I will observe this point, which is this also, which is this, something like this. But if you look very well, they are together, which means this line is the same with this line here. So if you should join this point, this end here to this point, you will get something like this. You will get something like this. So the view I'll be seeing while looking at this direction will be this and also this. Now drawing it on your orthographic projection, you have to make use of the measurement. So here is 70 millimeter. First of all, I will draw a construction line, which is a fence line, 70 millimeter. At this point, I'll mark out 70 millimeter. This is 70 millimeter. Project these lines up. Now, from this point to here, which is from here to here, is 15 millimeter. So I'll mark out 15 millimeter. And also from this point to this point is 50 millimeter, which is from here to here, 50 millimeter. So now I've gotten the front elevation, or you can call it the front view. Okay, before I go to the side, let's draw the plan. Now, the plan view is gotten you looking directly on top of the object, directly on top of the object, whereby the object has been placed already opposite your sight, looking the direction of the arrow X or any alphabet they call it. So if I'm looking at this object in the direction of the arrow and also looking directly on top of it. Now I'm looking directly on top of it, but the object is actually kept opposite me. So what am I going to see? I will see this point here, this point here, and also this point here, this surface. I will see this surface and also see this surface. So I know some of us might want to draw the plan. Since I'm looking it like this, let me draw the plan like this and also like this. No, what I mean, you keeping it opposite you, is, for example, you tilting this image like this, making it opposite. So since I'm seeing here, I will get something like this, and also this object here, which is the surface, I'll see something, I will get something like this. So this will be our plan view. Now we'll draw it on the projection plane. So using the measurement from this point to here, which is from here to here, is 15 millimeter. I'll measure 15 millimeter. I'll measure 15 millimeter. Mark out 15 millimeter.
It also indicates how the wave marker 15 millimeter from the ruler.
Okay. 15 millimeter, if you look very well, from here to here is 1 centimeter. In meter, it means 10 millimeter. So since it's 15 millimeter, that means 1.5 centimeter will be what? 15 millimeter. So 15 millimeter is in between 1 and 2. So in essence, 20 millimeter will be 2. And my 70 millimeter I did was 7, which is 70 millimeter. So 15 millimeter is from this point down to this point, in between the line which is longer, in between 2 and 1. So this is my 15 millimeter. Then from this point here to this point, which is from here to here, is measured 30 millimeter. So I'll mark out 30 millimeter, which is from 1 to 3 is 30 millimeter. So that's for the plan view or plan elevation. This is the front elevation slash view. This is the plan, sorry, this is the plan elevation stroke view. So now the angle drawn here, I will draw the angle now, which is at angle 45 degree. So this is your 45 degree set square. You use that to get the angle there. So after that, I will draw the angle which is at angle 45 degree from the projection line. Remember, I did a vertical line and the horizontal line. So the center point, that is where I will draw the 45 degree, the line at 45 degree, using my 45 degree set square. Then I'll project these lines or the outline. I'll draw line from the outline to touch that angle or that line which is drawn at 45 degree using construction line. Construction lines are thin continuous line. Project it to touch there. This I've already done it. So after doing that, you take the lines vertically upward. Vertically upward. It should be straight. Mind you, it should be straight. Vertically upward. Then also I'll do the same thing for my front view. Project these outlines. The line from the outline to this point. Do this also, and also at this point. Okay, if you look very well, the side view is already out, but I actually want to show you how we got it. Now remember I told you that at this point we'll draw the right hand side view, while at this other side we'll draw the left hand side view. So now, since we are drawing the right hand side view, this image is meant to be looked in this other direction, since it's the right hand side view. Remember, if I'm facing like this, automatically this side will be my left hand side and this side will be my right hand side, meaning I'll be looking at this image in this direction. But before that, let me show you, if for example if you're looking at this image in this other direction. Remember, the first thing to do, you assume that the object is at your eye level before taking any before drawing any image. So if I keep this object at my eye level and I look at this direction, what I'm going to see will be this L shape I'm seeing here. This L shape looking in this form. That L shape, that is what I'll be seeing. So now, if I'm looking, since I'm seeing L in this place, also I'll also see L shape in this other side, but the inverse. So if I'm looking it at this direction, what I'll be seeing will be L shape in this other direction. Hope you get. So if you look closely, after drawing this outline, you can see that this L shape is already coming out, which is this. It's already forming out, which is this. So, but if you don't understand and you know that you have such an image like this, you have to work with your measurement. That means you have to draw it without using this outline, but it must be on the same level with the front elevation. So from this point to this point is 65 millimeter, and from this point to this point is 30 millimeter, while from here to here is 15, which means 30 millimeter plus 15 millimeter will be 45 millimeter. That means from this point down to this point will be 45 millimeter. So from this point, if you measure it, you will see that it's actually correct, which is from this point to this point is 45. and the height, which is 65, if I measure it, it's actually 65. Then here is 15. From that point is 30. That's at 30. And here is also 15. So guys, that's all for this question. Here is my um right hand elevation or view, or you can say end elevation. Thank you.